Hello and welcome to my channel Stat Academy. In our channel, we should try to solve problems based on statistics. Today we are going to discuss about the problems on measures of central tendency. So before going to the problem, just take a quick look on what is central tendency of data. So there is a common tendency of data or varied values to cluster around a central value. In other words, most of the values lie in a small interval about a central value. This characteristic of data is called the central tendency of data. Now the most common measure of central tendency is arithmetic mean or simple mean. Suppose we have a random variable x and it takes n distinct values, say x1, x2, up to nth term xn. Then the arithmetic mean or simple mean is denoted by x bar, which is equals to the sum of all these values divided by the total number of value, or x1 plus x2 plus up to nth term xn divided by the total number of values, that is small n. It can also be written as 1 by n summation over I ranging from 1 to n xi. So the formula of simple mean or arithmetic mean x bar is 1 by n summation I from 1 to n xi. Now move on to our problem, which is taken from the book Introduction to Statistics by Prashant Kumar Giri and Giri Banerjee. The problem is taken from the chapter Measures of Central Tendency of class 11. The statement of the problem is, suppose each value of a variable x lies between p and q, both values inclusive. Show that p is less than equals to x bar less than equals to q, where x bar denotes the mean of x. So let us take the values of the variable as x1, x2, up to xn. Then, as the statement mentioned that each value of the variable lies between p and q, hence xi is greater than equals to p and less than equals to q. We use this sign greater than equals to and less than equals to because we have said that both values inclusive for all I from 1 to n. Now if we take sum to all of three values, then we have I from 1 to n p is less than equals to summation over I from 1 to n xi is less than equals to summation over I from 1 to n q. As p is a constant term, if we sum this constant term p up to nth term, then we have p plus p up to nth term, and it will give the values n into p is less than equals to summation over I from 1 to n xi is less than equals to, again q is another constant, and if we add this value up to nth term, then it will give the value n into q. Now if we divide the whole equation by n, then we have n into p divided by n is less than equals to 1 by n summation over I ranging from 1 to n xi is less than equals to n into q divided by n. If we cancel this value n in both sides, then we have p is less than equals to, we know that 1 by n summation xi means x bar or arithmetic mean is less than equals to q. Hence we proved our above statement. Now move on to our next problem. The statement of the problem is, a variable assumes the values 1, 2 up to 7 with frequencies 1 square, 2 square up to 7 square respectively. Calculate the mean of the variable. Now this is a problem on frequency type data. So the formula for mean of frequency type data is x bar is equals to 1 by n summation over I ranging from 1 to n xi into their corresponding frequencies fi, where n is equals to summation over I from 1 to n fi. That means the sum of all frequencies into summation of xi into their corresponding frequencies. So we use this formula for this sum. We have said that a variable assumes the value 1 to 7 with frequencies 1 square, 2 square up to 7 square. If we write this problem as x bar is equals to the sum of all values with their corresponding frequencies, then we have 1 into its frequency 1 square plus 2 into its frequency 2 square. In this way we should proceed up to 7 term 7 into 7 square divided by the total number of frequencies, that means 1 square plus 2 square plus dot 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 up to 7 square. Now we can write this as 1 cube plus 2 cube plus up to 7 cube divided by 1 square plus 2 square plus dot dot up to 7 square. Now we can see that this is a sum of cube of first n natural number. We know that sum of square of first n natural number is 1 square plus 2 square plus dot 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 plus n square. It will give the value n into n plus 1 into 2n plus 1 divided by 6. And again the sum of cube of first n natural number is 1 cube plus 2 cube plus dot 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 plus up to n cube is equals to n into n plus 1 divided by 2 its whole square. So this is for first n natural number. Now in our problem we have n is equals to 7. So we can write this as, for the numerator we can use 7 into 7 plus 1 whole square divided by 4 and into 1 divided by 7 into 7 plus 1 into 2 into 7 plus 1 divided by 6. So we have equals to 7 square into 7 plus 1 means 8 square divided by 4 into 1 divided by or 6 divided by 7 into 8 into 2 into 7 means 14 plus 1, that means 16, that means 15, sorry, that means 15. So if we cancel this 1 7 with 7, we have 1 7 and 8 with corresponding 8 and we have 1 8 and 2 2s are 4, 3 2s are 6 and 3 divided by 5. So we have is equals to 7 8s are 56 divided by 10, that is equals to 5.6. Hence the mean of 1 to 7 with frequencies 1 square, 2 square, 7 square is 5.6. Now moving on to our next problem. The statement of the problem is, what is the arithmetic mean of 7 7 7 7 7 up to pth term? So the mean of this series is P7 plus 7 plus 7 plus dot dot up to pth term divided by the total number of term, that means P. So we can write it as 1 divided by P If we take 7, then we have within bracket 1 plus 11 plus 1 1 1 plus dot dot up to pth term is equals to 1 divided by p 7. If we multiply the whole thing by 9 and divide it by 9, then we have 7 divided by 9 and multiply with 9, 9 plus 99 plus 999 plus dot 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 up to nth term is equals to 1 by p 7 by 9. We can write 9 as 10 minus 1 plus 99 as 100 minus 1 plus 999 as 1000 minus 1, and in this way we should proceed up to pth term. Okay, here we have pth term is equals to 1 divided by p 7 by 9. Now if we break the series in two parts, one as 10 plus 100 plus 1000 plus dot 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 up to pth term minus 1 plus 1 plus dot 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 up to pth term. Again we can write it as 1 divided by p 7 divided by 9 into 10 plus 10 square plus 10 cube plus dot dot up to pth term. And if we add 1 up to pth term, then we have 1 plus 1 plus p 1 plus 1 plus 1 up to pth term, that means p into 1 or p, so minus p. Now we can see that this series is a GP series, and we know that the sum of GP series up to pth term is the value 10 a into r to the power p minus 1 divided by r minus 1 when r is greater than 0. Here a is the first term and r is the common difference. So for our problem, the value of a is 10 and the common difference is also 10, that is 10 to the power p minus 1 divided by 10 minus 1. So if we can write this as is equals to 1 divided by p 7 divided by 9 into 10 to the power 10 into 10 to the power p minus 1 divided by 10 minus 1 minus p. So if we simplify this, then we have 70 divided by 9 into p into 10 to the power p minus 1 divided by 9 minus 1 by p will cancel. We have the value 7 divided by 9. So the mean of this series 77777 gives this value. So this is our answer. So that's all for today's video. Thanks for watching.